Hello to you again. All right, let's continue with solving systems of equations. And this one is a quadratic system. So we have this system is given by this relation that you can see, number one, and the second one is x plus 2 all squared over 9 plus y minus 1 squared over 4 equal to 1. The first equation represents a circle, okay? So that means you need to remember everything about circle, how to graph it, how to find the center and the relationship. The second equation, this one, is an equation of an ellipse, and you need to know that as well. Okay, everything about it, major, minor axes, how to graph them, how you find the center, and you can definitely go back and check out the videos that I have, and I will put a link to it at one point in one of the cards, both of them, so that you can go back and check. But that's what we're going to do. Now we're going to start with the graphic solution, and we're not going to use technology because this is straightforward. So let's go ahead and let's do this. The first thing that we're going to do, we're going to graph the circle. Okay, center of the circle is, so let's number this, number 1, number 2. So instead of rewriting the entire circle equation, we want to find the center is -2 and +1, and the center for the ellipse is again -2, 1. So that means both of these two guys, they have the same center. We're going to plot the center coordinates, -2 and +1, which is right there. Okay, so that's the center for both. Very good. And I'm using the grid already so that you can see it. All right, 2, 4, and that's -4. All right, and then so forth and so on. And let's graph the circle first. So the radius of the circle is important to have. So the radius is 2 units. Because of this 4, you take the square root of 4, that would be the radius. So from the center, I go up to 1, 2, that's one coordinate. I'm going to come down to, I'm going to go to the right of the center, I'm going to go to the left of the center. And then you're going to graph or draw, if you can. I'm going to do a freestyle. Draw a circle that looks like this, okay? For a freestyle, that's not a bad draw. Okay, now let's graph the ellipse. So a couple of things you need to know about the ellipse. First of all, okay, let's write up the center. Center is the same. There is no radius for ellipse, but they have major and minor axes. All right, so the major and minor axes, they are here. So that's the major axis, that's the minor axis. Actually, they are not it. You have to extrapolate the information from that. But remember, that these numbers, they are squared when they're in the denominator. Okay, so whichever is larger under that variable, so in here is x, so x is the horizontal value. That means that the major axis now, it is horizontal major axis. So let's write up information that we have. We have a horizontal major axis. What is the length of that? Well, that is the square root of 9. Whatever you get, you have to multiply it by 2. So that would be 6. Okay, that is the length of the major axis. And then what is the length of the minor axis? And that is a vertical, by the way, and that is 2 times the square root of 4, which is 4. Okay, very good. Now once we have this, now we can go ahead and draw the ellipse. Now we're going to use the major axis, so 6 units right here. Okay, so to do that, from the center, we're going to go 3 to the right, 3 to the left. So 1, 2, 3 right there. So from here, we're going to go 3 units to the right, and then we're going to go 3 units to the left. We're going to go, and then for this is the major axis, so we know that that's true. And then for the vertical, which is the minor axis, that's the vertical, we're going to go 2 up and 2 down. You go up 2, 1, 2, and then you go down 2. And now you're going to graph. Now it's supposed to be pretty smooth and an ellipse, not a football shape, but you get the point. I'm doing this freestyle, and here it is. So that is the ellipse that we have. Now, what you need to see is the point of intersections of the two. Okay, one is in here, one is in there. So what is the coordinate of each? The first one, 1, 2, 3, so -2 and 3. Next one is -2 and -1. Those are the points of intersections for this system. Now, how do you check these? Okay, how do you check? Well, if we have these coordinates, you need to plug them back in each of these equations and make sure that it is true. So you plug in the first point, -2, -1, in here for the first equation or the second equation, doesn't matter, but the left-hand side must equal to the right-hand side. So now that you plug in the number -2, -1, and you can see that it is equal to 4. Okay, and you can do the same thing for -2 and 3. You plug it back into maybe this equation, the second one, the ellipse equation, and then you'll find out that the left-hand side will be equal to 1 as well. So this is the graphic way, solving it graphically. Now, a challenge, and challenge is, what if you want to solve this algebraically? How would you do that? And that is the part that it can get algebraically intense, but it can be done. So, and you have to use substitution. That's the simplest way to do this, substitution. And since y minus 1 squared or x plus 2 squared, you have them in both equations, you can easily substitute one for another and then go ahead and solve. But in reality, you're not going to get that question solving this system algebraically. It takes time to do this problem, obviously, because of substitution and few things, but it takes at least 5 minutes to go through this problem. So, and it's not impossible. It's actually okay. It's just algebraically intense, and it's not hard. It's just tedious. But what I like to do now, I like to go to Desmos and actually graph these two guys and then show the graph to you in a more clear, nicer way than this cartoonish graph that I put up here. And it's a freestyle. I get it. And that's what you would do as well. But to double check to make sure. Okay, so let's do that. So here it is. I typed in the equation of the circle, the equation of the ellipse, and you can see that this graph, the blue graph is the circle, and then the white graph is the ellipse. And this is the point of intersection right there. That's one of them. There's another one right here. And this is what you get. And so we did we did a good job of solving that system. Notice that the center is the same for both, and that's what makes it a little bit easier. But generally speaking, you can really use Desmos to figure out solution of any system, especially with the quadratic and quadratic, or a system that are like exponential and radical, or a relation where you have, for example, instead of an ellipse, you have a hyperbola. Okay, if you found this useful, subscribe, like, and comment, and hit that notification bell so that whenever I post a new video, you'll be notified. Until next time, keep at it.